Yes, sir. It is visible.
Okay, fine. Thank you, sir. Okay, so morning, good afternoon to everyone. So let us back on our discussion. Morning, I have discussed about introduction to bipedal locomotion and push recovery. And this time I'm going to show you application based on this one. And some work which I will display later on. And this time we'll learn some experimental things also, in which we'll see how to implement human activity recognition code in the deep learning using Python. So this also we'll learn. So let us start. And the topic of my talk is right now moving toward design of data-driven computational model for human activity recognition using TinyML and deep learning. Okay, so here data-driven techniques mean we are now relying on data. We are capturing data for human being gait data, walking data, and that data we are utilizing to design the model, computational model. So computational model, whether it is deep learning model or some machine learning traditional model, and especially human activity recognition related to lower extremity. It is related to walking only. So the detail of my presentation will like in this case, I will discuss about detailed workflow, data collection, data processing, we are dividing training, testing, validation, and all other sort of things will understand. So first part, I will discuss about human activity recognition. What is human activity recognition? How we are collecting data, how many different activities data we have captured. Okay, how gait is helping to monitor the human health. Okay, how you can monitor the human health, how accurate it can monitor, what parameter it can decide. And the second section I will discuss about how TinyML. TinyML is the compressed machine learning model, because I will try to use or support the edge computing. In edge computing, we have a limitation, that very limited memory power. Okay, in Arduino board, if you want to use certain codes, so Arduino board has very limited flash memory. So how you can compress such a big deep learning or traditional machine learning code? That thing will deal here. So already we are aware now, and I'm expecting you are knowing about gait, walking patterns. And here human gait refers the locomotion achieved through the movement of human limbs. That means with the help of left and right leg, whatever motion you are able to generate, that is defined as locomotion or gait. Already morning we have understand what is bipedal robots, what is phase-wise division of robots. So human gait is defined as bipedal. That means with the help of two legs we can move. So the machine or model or device which has two legs, which can walk with the help of two legs, is considered bipedal. Biphasic, that means phase-wise division. It is a non-linear system, and to study non-linear system, you have to divide into phase-wise linear phases. Then only you can understand. Entire universe is non-linear. Whatever you are perceiving through your eyes or from environments, it is non-linear in nature. You have to do piecewise linear. As morning I was showing hybrid automata model. In hybrid automata model, I have divided into 8 subphases, human gaits, like initially swing phase and stance phase. Then further division is that pre-swing, mid-swing, initial swing, mid-stance, terminal stance, and like this I have divided into 7 discrete subphases. So these 7 discrete subphases are 7 linear classification of non-linear system. That means that particular time we have similar parameters. So that's why biphasic means we have swing phase and stance phase. So the gait is defined as bipedal with the help of two legs. It is biphasic, which is further divided into swing and stance phase broadly. Okay, and forward propulsion of the center of gravity of human body. So we are moving toward the center of gravity of human body, and this forward propulsion is applying force so that we can move in the forward direction. in this movement, there are alternative sinus movement of different segments. That means alternative sinus movements is related to your left leg and right leg. There is two portion of brain, left hemisphere and right hemisphere. If you are left-handed person, your right brain is more activated. If you are right-handed person, your left brain is more activated. And you can visualize this also. You can visualize this behavior. Typically, if you apply force on the left-handed person, it's the right foot will run first. And if you are a right-handed person, it's the left foot will come front first. So it shows that the movement which is generated through the motor skills which you are effectively learning is also governed by your way of walking or your way of working. So whether you are left-handed person, right-handed person, it is also affecting these things. Okay. So this is alternative sinus movement of left and right leg, left swing, left stance, right stance of the body, and the objective was the minimum energy. So with the help of this is very typical definition is defined of the gait. The gait is defined as bipedal, biphagic for a population of center of gravity of human body, in which there are two legs are participating, that is sinus movement of different segments of body with least energy expenditure. I hope that this definition is clear. And here I will try to correlate how you can monitor human health using as IoT application or as computing application. Human gait pattern are helpful in identifying useful insight already discussed in the morning. We can analyze the human health. We can also use as a biometric identification. We can also see the posture stability, mental status. Okay, it's affected by several factors that also I'm going to do. Inside of the body type movements and posture state. Gait cycle also I very well define. It's involve at least one foot in the contact with the ground at all the time. And when same foot are also continuing, then we consider, maybe I have not moved my slide so far. So that's why this is on the first slide only. I'm explaining each and everything. Okay. So when a foot is in the contact with the ground, the limb in the staff is. Now you can see that my slide will move. Here I will introducing new term, that is gait velocity. So for gait cycle, step length, style length, everything as explained. The gait velocity is the habitual of walking speed adopted by the person in the everyday life. Like suppose particular person is walking 2 kilometers per hour, 3 kilometers per hour, 4 kilometers per hour. So this is considered as a gait velocity. That means your walking speed adopted by the person in everyday life. Medical researcher has found great interest in gait velocity. Compared to other gait parameters, the gait velocity is a great measure of human health. So they have considered it is gait velocity is an important health metrics. To analyze human health, it is very important. Now, when we're talking of walking, and it is helping us to understand the health are very important. So what things it is affecting and what we can measure regarding health issues through the gait velocity, that I need to make you clear. So walking exercise involves the nerve system, cardiovascular, you are related to heart, pulmonary, you are related to stomachs, musculoskeletal, and hematological system. So whenever you are performing walking, you are also involving in nervous system, cardiovascular system, pulmonary, all things are going to activate it. That means getting oxygen. It requires more oxygen. When you are walking, that's why you used to get tired also. Okay, you require more oxygen. So to contact the muscles. Okay. Impairment in one of these systems, that means there is some deficiency or some defect. If it is occurring in any of the system, it will impact the person gait velocity. That means you will not able to perform your walk or speed as efficiently as you are doing. If you are affecting with any nervous system or cardiovascular, pulmonary, or any sort of disease, if you are suffering, your gait velocity will affect. So that's why medical researcher scientist or doctor community has accepted this as a important mathematics for the human health. You can refer the literature regarding this one. So physician has called gait velocity as a better predictor of various health issues. What are these health issues that I will discuss now? Okay, and for time being, you can see this diagram which is depicted here. This is stick diagram, dark black and the small black. Okay, so what is there? There is two sinus which is participating and their movement is there. If you see that we are starting with here hill style. This is my hill style phase. Again, Sam put his contact on this ground. Then I can say that this is one complete gate cycle. Okay. And in between you have left and right leg, both are participating. Both are coming in swing and stance phase. So your gate cycle is starting for right stance phase. For 60% of the time is the stance phase, then it is coming swing phase. Similarly, for left leg, it is swing phase, it is starting, and then we are coming in the left stance phase. And I have designed one cellular automata model rule-based system, which also I will discuss later. That time I will consider these parameters. Okay. In between, you will be in double support phase. Double support phase is this phase, where both foot are in stance phase. So what is happening? If I will define gait cycle, this is right stance phase, left plus right stance phase, and then left stance. It is clear. Anyone who is having any doubt, they can ask, they can write in chat box. I'm continuously watching chat box so that if any doubt anyone is finding, I can answer this. So it is three stance phase, right, starting with the right stance phase, then both stance phase, left plus right, and then left stance phase. That is one complete design. So different people has referred as gate different way. It is their way of explaining or defining the gates. Okay. So this is double support phase 2% and 2% double support phase is coming here. Again 2% double support to total. I think that in one gate cycle we are getting 10% of double support phase. Rest 90% of time we are getting single support phase. Now already introduced locomotion in morning. What is locomotion? Now we'll see that how we are acquiring. This is locomotion of coordinate left and right leg walking in the forward direction. And in our experiment, what we have done, we have considered different subjects, and I have used mobile phone for at least 30 subjects. Out of 30, 15 was male, 51 female. Some were a left-handed person, some were right, because we have before starting, we have to select the subject in such a way so that we can generalize our outcomes. Okay, if we have a variety of inputs and we are generalizing our output, that is great achievement. So if you see that, if you refer these first two diagrams, in this case I am using mobile phone. These are the mobile phones which is enabled with the IMU sensor, inertial measurement unit, IMU, inertial measurement unit sensor, and that is 9-degree IMU sensor, 9 degree of freedom IMU, inertial measurements. Out of this 9, 3-degree for accelerometer, 3-degree for gyroscope, 3-degree for magnetometer. Accelerometer is related to acceleration, which is just giving positioning around XYZ axis. 3-degree gyroscope, which is giving orientation or rotation around XYZ axis. Again, 3-degree rotation, and 3-degree magnetometer, which is somehow doing the job of accelerometer, but it is not drifting with the gravitational force. That I will discuss in depth when I will discuss second portion. and I will explain how data is collected, how data is pre-processed, and how the code is written and what code outcome is there. That I will discuss that time. Another I've used, this is Bluetooth enabled IMU sensor. IMU sensor you can get easily. Okay, it is again 6-degree IMU sensor. It has accelerometer and gyroscope, no magnetometer. So it has place on the knee and ankle and hip for both leg. It is done. So that is in the constant laboratory environment. We try to capture the outside laboratory also. The another techniques in which I'm not using kinase, this is IMU sensor. I'm using kinase sensor, and the kinase sensor is placed here. And we have concept multi-degree kinase sensor, multiple sensor, kinase sensor. Regarding this, we have publication also IEEE sensor. So it is, again, we don't require to wear any wearable sensor like I was wearing in IMU sensor. For IMU sensor, we require the permission from the author or the subjects which is participating. Apart from there, we have to take ethical permission. It will not hazardous for the human health. Then only people can wear. In another scenario, when I'm using kinetic sensor, which is basically stereo camera inbuilt. It has variety of sensors and it is very helpful. Okay. So which is placed bit far, and it is just drawing a skeleton, and I will demonstrate what output is it is giving. In this case, we have also considered the occlusion base where multiple people are working together to capture this data. If you can see my video, the guy is coming and it is performing the work in front of camera. How camera will process? Camera has RGB images, so it will capture the red. This is just depth image. This is RGB image of the person walking. And now this is studio camera, what it has written. It has given the skeleton. There are 25 joints in human body, and you can refer this diagram. 25 joints. These red dots are showing the joints available in human. By default, these joints are extracting pattern of joints. Okay, you can analyze diet joints. Somewhere in computer vision, people are using black color cloths and then placing the white color on the joints so that by pixel intensity also you can capture the data. Okay, so in this case, you have already seen that the person is walking and I am able to trace person data. Okay, so what is happening in this case, you can have different values. Okay, then I have asked to perform a little bit fast work through this sensor only. In this case, the person is walking fast. Again, I am able to traverse or track these joints. These joints value, I will explain how we have captured and where we are recording. This also I have kept. Then this case, very slow. So I have asked to perform different sort of work, slow, bit fast. Then we have asked to do some other exercise, push-up. The person is sitting and upping, so joint coordination are moving according to their plan is also participating. Okay, it is. This is like jogging. The person is moving here and there. All body portion is joints are traced, and according to this data, you will find the value according to each body joints. Okay, how we are getting these values, I will show. Apart from there, I have captured the data from multiple person when two person is working. You can see that the occlusion is happening when one person data is going to hide by another person data. Some portion are going to hide. In this case, what will happen? It is drawback for us. We are not able to perfectly capture the some regions. For this, we will apply numerical interpolation. This is in treadmill, and I was running. So it is that data we have captured on different species in the treadmill data. So for human activity recognition, I'm using a different sort of sensors, whether it is wearable or kinet sensor, which is not wearable sensors, trying to acquire different sort of activity which is related to lower extremity, which is ultimately utilizing the gait. Now, I think already maybe Professor Nandi has shown these videos, how we have collected data for human gait using another techniques, famous technique. That is which this suit is designed. In this suit, we have used 8 accelerometer, potentiometer, and one Arduino board. All potentiometer are connected with Arduino boards, and it is connected through wire LAN to our through USB to laptop. But now it is wireless. By Bluetooth also you can transfer the data, and the person is walking and we are capturing data. So somewhat it can help us to design the exoskeleton, robotics prosthesis, capture the data, trace the activities. This is what we are capturing the data. The data you can see in the Excel sheet. And you can see that very sparse zero is coming in this data. That means that time these joints are not activated. Okay, so these data, so you have to apply pre-processing data like data smoothing. Okay, so where I'm not getting any data due to sensor error or something that time, because the potentiometer which is bind over the human joints are not that much flexible. Somewhere you are getting constant value. So these kind of issues you will come when you are taking real sensor data. So to pre-process the data, we have to apply pre-processing technique like data smoothing, data averaging, data normalization technique we can apply, by which we can edit. The HLPRCT already data, professional is working. In this case, again, I have used this potentiometer sensor by which, sorry, mobile phone sensor, which has 90-degree IMU sensor. It is used any Android phone. So there is one software, physics to the accelerometer, which help us to capture this data, sensor data. Sensor data has lot of noise. So that noise we have to remove. Okay, the noise removal techniques we have applied, by which we can perfectly capture the data. Okay. Then after that, there is very famous techniques. There is robotics by solving the inverse kinematics problem of two-link manipulator, because human leg is considered as a two-link manipulator, and you can easily calculate the joint technique, because accelerometer will give you xy pair of values by which we can capture the data. Now this is important analysis regarding push recovery. Maybe you have already seen, but again I am running. In this case, what is happening? The person, the girl, we are applying certain force from behind. The pressure sensor applied on the back of that girl, and it is very small size area wise. So we are using wooden hammer so that we can apply uniform pressure over all the points of that force sensor. Okay. Again, it is connected through the Arduino board, same setup which I have used previously. Potentiometer, 6 potentiometer is placed on the 6th joint. Left hip, right hip, left knee, left ankle, right ankle, and one extra potentiometer force sensor is placed. the force sensor is duly calibrated with the weaving machine. After that, what is happening? Whatever Newton force we are applying, we are seeing the observation how their joint angle of hip, knee, and ankle are going to change with this one. Ultimately, they are all connected with the Arduino board through Arduino board to machine. So here you can see that I have tied the eyes of that girls as well as hand. The reason is that robot cannot see from which direction force is coming. If we know that from this particular direction force is coming, we can take some reactive action and precautionary we can save ourselves. That is what reflexes I was talking about in morning. Human gait is a reflexive process. Similarly, reflection is there. Automatically we'll try to save, but we want the natural environment. And second thing, we have closed the hand because hand movement also helps us to recover, because hand will generate extra torque, and our interest were only lower extremity, that means hip, knee, and ankle. So that's why we have tied the hand also, so that hand movement cannot be generated, which can make the body stable. Okay. Now you can see that different magnitude. Initially small magnitude force is applying. She is involving only ankle. After that, she will involve hip also. And then ultimately she will take stand. So we are applying force until and unless she will not able to recover and she has performed stepping. Good morning. I discussed small force, medium force, large force, ankle strategy, hip strategy, and stepping. After that, we'll expect the human being will not fall. Then we have considered another person. In this case, we have not tied the hand. The girl is applying force from behind the force sensor, and we are seeing the stability of different sort of things. Currently, we are using EMG sensors in which we are trying to apply the EMG sensors also, how this muscles activation is happening. 1 minute. Huh? Sorry for delay, and there was some interrupt. And okay, so I was discussing about how human behavior is changing when we are applying different force, and we are trying to capture this force, and we found some interesting observation. If I'm very much interested to share with you. One is that if you have left-handed person, your right foot is coming front. If you are right-handed person, your left foot is coming front. You can see also, and you can try at home, your home also today. Second observation that it is highly non-linear. as it depend on age, weight, your gender. If you are male, then it has different push recovery capability. If you are female, then different push recovery capability. Apart from their, it depend on whether you are athletes, normal human being. Athlete has better push recovery capability compared to normal human beings. Okay. Your mental status, if you are lethargic or you are totally tired, that time you will have different capability. So much variability is there, and to design the robots or activity recognition, we cannot go by this way. Okay. So already I told that morning I am not discuss about. Now I am going to discuss. This is 3D visualization of software in which you can perfectly to see that it is human skeleton. This is thigh, shank. These are the different joints. Okay, this is your torso point connecting with the torso, and this is point also considered as center of mass. Male and female has different center of mass. That's why stability also going to affect. And this is 3D visualization. The force which we are applying the force, and you can try also over force plate, which currently I was utilizing this force plate. Okay, and if you see that IMU sensor to capture this one, it has placed one IMU sensor on heart to monitor your heart rate, because ultimately heart rate also important measure for your health monitoring. Then you are applying on the knee joints, left and right, and ankle joints. So this way, and we are also connecting on your hip joints also. Okay, so it depend on you where you want to place IMU sensor. Same IMU sensor is placed. And we have also used these IMU sensor on heart to heart rate, hip, knee, and the treadmill to capture the data on different speeds, so that gait velocity can become the popular to visualize or analyze the human health. Okay, so this already I discussed. Another technique is that to place the markers, reflexive marker for motion capture. So in this case, what is happening that the markers which is reflecting in the night, it is like night. You have seen that many times we are wearing such dress, the reflectors are there. Similar way, we have placed the reflector on the hip, upper hip, lower hip. Okay. Similarly for thigh, knee, and ankle. So this we have placed. Based on this placement, what is happening? Reflectors. It is because there is white color markers, it will have more pixel intensity, so you can easily able to capture these joints values. Okay, these white value, and we can capture. And there is three plan view already we have discussed: sagittal plan, frontal plan, sagittal plan, black view, and top view, by which you can capture. So this is all what we are doing. It is to capture the human motion, human walking speed motion. For this we are doing. This also I discussed that you can perform the walk over different terrains, flat terrains when the street flats. So it is quite easy to walk when you are going for inclined plane on this, and there's something you can perform on treadmill. You can increase the inclination angle, 20 degree, 30 degree, 40 degree. You can perform the walk over the treadmill. Some experimental setup you can set for the different inclination ground. Then you have a staircase. Okay, staircase size also you can fix as at least you have seen that we are trying to demonstrate certain park our kind of abilities. You can have different shape of walls and this, so that you can walk and you can travel over the uneven ground, and that is rugged ground. This already I discussed, so I'm not going this discussion. That is what entire gate is divided into surfaces, and that is through the open sim we have captured. Morning someone has asked, can we solve the inverse kinematics or kinematics parameter we can get from open sim? Yes, we can get, definitely. So there is loading response, mid stance, terminal stance, free swing, initial swing, terminal swing, and these are the divisions of the human walking. According to them, parameter and posture is changing. There is muscles. These are blue are lines are muscles. So maybe you can remove muscles also, or simply you can apply kinematic model. Once you are involving the muscles, the force is generating. Due to this, the dynamics is also involving. And to avoid the dynamics, if you are only interested for kinematics, you can just remove the muscles, because muscles is working like actuator, okay? And the actual actuation is happening at the joints. So human body is entirely under actuated system. It is not fully actuated system. All the joints are not going to activate it together. Only few joints are activating that particular moment of time. Okay. Now, after seeing this one, let us see the metrics by which we can justify how gait speed, gait walking is helpful to identify the human health. So you know that blood pressure, breathing cycle, body temperature, and pulse. These are the important parameter by which you can assess the human health. Okay, so apart from there, researcher has suggested that the walking speed of the person could be better predictor of health issue, and the health issue involves cognitive decline, fall, and even cardiac and the pulmonary diseases. So what we can do, we can also check cognitive decline. Cognitive decline, like neural system is going to dead after certain time. Okay, and also your memory capacity is going to decline. Fall, which is again related to post recovery, and the certain cardiac and the pulmonary disease. So for this purpose, we will show one matrix. Okay, I will show one matrix. Maybe this will appear after some time. Okay. And the research gap is there. Walking speed detection using sensor prove cost ineffective and a complex to set up. Okay. This is the problem, that once we are involving sensors to detect the walking speed, it is not only involving cost, it is complex to set up. Wearable devices are too difficult to wear, and then you will not get accurate data. A lot of noise will come. Second, that old regression methods are not also precise enough, which is helping us to predict the further steps. The feature engineering level used for feature extraction is also very challenging task, especially with the old machine learning. So people are moving toward deep learning so that they can itself extract the better features more. Sensor-based method are also non-portable, like mobile phone, and there are many restrictions such as range. They cannot be used for continuous analysis. So that people are using such a device which involve such a mechanism by which we can avoid these techniques. Okay. So for our experimental purpose, we have used Arduino Nano BLE Sense that I will show in the second page of talk. But what gyroscope, accelerometer, and magnetometer is doing? In sensor, you have three axes, X and Y, Z. Gyroscope is telling rotation around X-axis, Y-axis, and Z-axis. There is G-force also. So you use to project detect the angle made by the different joints. All smartphones are equipped with the gyroscope sensors. That's why we are using mobile phone. And mobile phone you can easily place in your pocket. Okay, so in this case, we don't need to wear all the sensors over different joints. You just place your uh, mobile phone in your packet. And these are, these are enabled with the IMU sensor, which have accelerometer, gyroscope, magnetometer. And this brings the opportunity to compute the data of angle using smartphone and predict the walking speeds. Okay, so for this solution purpose, we have used this data. Okay. Now, coming on the application domain, and IoT is finding the quite popularities, and that's why we have to propose the IoT-based solution for this human health monitoring using gait analysis, which is becoming. If you'll see that healthcare almost 30.3%, it is as growing rate percentage. Security also 7.7, and gait is going for two areas. One is healthcare, another is security aspect. Okay. So people has tried to correlated this problem as a Internet of Things. So what they have done, they have developed the body area network, BN. In this case, the person is wearing different sensor like ECG sensor to record brand, EEG sensor, EMG sensor to muscle activation, and there is motion sensor one, motion sensor two, motion sensor over different part of body. Their sensor is just sensing, okay, omnidirectional sensing, and after that, once they have sensors, they are sending the data over mobile phone, okay. The mobile phone is there, and then to publish data over internet and to perform basic computation to assess your health, what data we have captured regarding your body motions. So for this, we have uploaded this data over cloud or fog computing or edge computing. All three things I will discuss: cloud computing, fog computing, and edge computing application. So but generally data is uploaded over internet. So different health companies are working which has predefined metrics, and automatically the moment they are capturing your data, it is going to map there, and they will capture your data, and then they will publish which kind of problem you are facing, okay. They are recording for future reference also, so that they can assess their. So as I am coming on IoT device, whether this is perfectly IoT device, so there is sensor and actuator, both are sensing from the environment, okay. So actuator, first sensor has sensed from real world, then design the intelligent agent, and then they are performing actuator to perform the particular task, okay. So I'm not going in this depth. And already I discussed about IoT application across industry. Smart head mounting is the demand of time, smart health grid, smart city, smart home, connected car, wearable gadgets. Nowadays you have watch, wearable watch, by which you can also uh, uh, predict the health of person, because they are using maintaining various health metrics in the watch also, which is connected through cloud. You can see also in your computer how much steps counts you have computed today. This sort of data we can do to prepare the IoT prospective IoT health smart health monitoring system. So we have designed this body area network, this entire architecture. So first phase is data acquisition, which is through sensor, sensing and transmitting. Second phase is connected data concentration, and that is cloud processing, fog processing. Okay, in edge computing, we are not using internet, so that means security we are using in edge computing, but in fog and cloud, we are using this. Then once the cloud has processed the data, then we are analyzing. There is visualizer tool like 3D and 4D, we are seeing the final. So for data acquisition, the human body is there, different sensor are placed over body. Nowadays, one interesting application that during COVID, the patient is admitted in the hospital. We have placed various sensor over his body. We can monitor what is oxygen level of that person, because generally they are not allowing to enter in the particular ward. So we cannot monitor our patient by body area network. Various sensor uploaded, we can see outside, oh, oxygen level is going to be down, so please reach there, the situation is critical, and this kind. So the body area network BN is enabled with the sensor, which is forming like wireless sensor, and then they are using protocol also, uh, TCP IP protocol for communication protocols. Their topology also, communication interface are changing, whether it's Bluetooth, Zigbee, and Wi-Fi. Once it is sensed, then through Bluetooth and Zigbee, they are transmitting over the local processing computer or mobile phone, that is concentrators, okay. And then ultimately data is uploading on the cloud set, which will process the data, and then finally it will provide the analysis, what is problem with you, what particular suggestions, feedbacks they can provide you, and finally in between you are consulting with the doctor. So now see the capabilities of various biometric or biomarkers where we are applying. If you see the gait posture, ECG respiratory rate in this. You can see that the column wise division. First is CVD, which is cardiovascular disease. Okay, CVD is the cardiovascular diseases. Then you have COPD, 1 minute. So if you see that gait is helping in the CVD, cardiovascular diseases, COPD, it is related to chronic obstructive pulmonary diseases, Parkinson diseases, Huntington disease. Only in diabetes it is not helping. Gait is not helping to analyze this disease. Yes, cardiovascular, pulmonary diseases, Parkinson diseases, and the Huntington diseases, it is helping to assess. Simply ECG device, respiratory rates, skin temperature, other measure. So you can see that gait is also very important matrix by which you can analyze different diseases. So we cannot ignore the gait. Gait has important analysis, and here we have proved that how important it is helping us to monitor the human health. Which kind of disease we can identify through this one. This. Now to design the deep learning model, which I will discuss next slide when I'm going for tiny ML, compressed ML. In this case, what is happening? We have analytical clinical testing. Doctor is there, always we have to verify. First, we have previous sensor data we have captured, because in machine learning we require the data by which we can train the model. And once model is trained, then we can test over the new data which is coming over there. Okay, so sensor is there. So through sensor previous data we have trained the model. We have built our machine learning model. Okay, and that machine learning model has designed the regression model or classification, whatever you want. Now the time is coming where new sensory data is coming current through, and for this we have to test whether it is which category data, whether person is healthy and unhealthy. So already build and trained model which is with the higher accuracy is there. Current sensor data is passing, and that data is also going to be consulted by doctor. It is not that machine learning model has predicted the data, and that is not going to be validated by the doctor. Maybe machine can predict false positive, false negative. This kind, true positive, true negative, false positive, false negative. This kind of things are happening. Okay, the clinical acceptable metrics has to follow, and diagnosis and the prognosis support required if particular disease is occurring. In this case, what particular solution and help can be provided to patient. This is doing through this one. So that is what entire workflow diagrams of clinical testing of wearable sensors. Okay. So IoT in healthcare is emerging domains. So basically it's involving heterogeneous computing. It is not that homogeneous like only you have wireless network or either Bluetooth network or wired networks. It is wirelessly communicated system to app device. Many different protocols and technology are involving. So you require interoperability kind of capabilities which can integrate. Okay. So healthcare with the help of this IoT device is opening the way for telehealth umbrella, which can telemedicine consultants, telemonitoring, you can perform telesurgery, remote medical education, and the telehealth data science things. Okay. Now, same problem can be defined as a cyber physical system problems in which you have sensory organ by which you have captured the data. So you can see that you have sensor and actuator and computing agents are there. This is what actual physical system and in embedded device. Okay. Then your data is over cloud for further processing. This is what cyber physical system when you have prepared the computational network, okay, and then center processing unit or by HMI port you can access the data. So that system also you can define the over cyber physical system. Now I'm going on that kinase sensor by which we have captured the data is given here. How data is capturing, and immediately after I will switch to the code. The kinase sensor has different sensors. It has depth sensor, it has vision camera, RGB, it has microphone array so that it can capture your speech, also voice. It has tilted base so that you can move. It has depth sensor to identify the obstacle. Okay, LED light whether it is working or not. So in the proposed data set or techniques, we have collected data for 15 subjects for the walking activity, natural speed, walking very slow, walking slow, walking medium, walking fast, walking on toe, walking on a hill and stair ascent and grades. So different data we have captured. So the moment we have captured the data, the Microsoft kinase sensor is studio kind of camera, which is giving you skeleton joints, 25 skeleton joints. Already I told. So this is 0 to 24 joints are there. Based on your utility, you can use, like I have utilized 12 to 19. Hip left, knee left, ankle left, foot left, hip right, knee right, ankle right, and foot right. This I have captured. Okay. So this is very interesting feature which provide the illustrative activities detection and monitor by the laying the skeleton image on the green. So already we have seen that these Z dots, this image was coming. We have interested only for these 8 joints. Okay. And the proposed techniques was there, in which we have used IMU sensor as well as kinase sensor. We have done fusion over both kinase sensor as well as computer vision based, IMU sensor. The data acquisition, then we have applied pre-processing techniques, data normalization. Then we have used probabilistic model. Then finally deep learning model, and finally we have built the model which can utilize to assess the human health, monitor the things. Okay. We have also collaboration with the Japan, Osaka University. So where we are doing to test over whatever data we have captured through different person or occluded or degraded. Especially we are interested for impaired person gay data when person has losing certain capabilities healthcare. Okay. Even we are interested for to monitor the patient sitting inside hospital. No doctor is visiting, but we can monitor from outside. The moment we'll find that situation is critical, is health monitoring in this, that time we can do. And data repairing we can do through the TGT and curve fitting techniques. The work further can be utilized for rehabilitation, stability, and biometric. Okay. And finally, Hosoi University will test over the model, whatever data will design database classification. And we are trying to involve EZ and EMG signals also. Okay. Now the joint angle calculation is important because already we know that accelerometer as well as kinase sensor is giving the values which we have to run, and I will show that what value I am getting through the kinase sensor. If you can see my screen, kinase sensor value you can get here, like multiple person data I'm taking, multiple people are working. Okay, these are the activities which are performing. These are the data over the treadmill where person is walking, and we are capturing data kinase. The data is recorded into JSON file, Java objective file. You can see that what kind of data we are capturing. So here I'm, so that you can visualize. Data is coming in this form. So as I told that kinase sensor can track 6 body. Each body it will provide index. Suppose I am tracking only one body and that body index is provided by 3. Tag ID is true and the tag unique tag ID is provided. Left hand state, right hand state joints. Now I'm coming on joints. As we told that there is 24 joints which is mentioned in this. These 24 joints are there. Corresponding E joints I'm getting depth X value, depth Y value, color X value, color Y value, camera X, camera Y, camera Z value, orientation X, Y, and Z. I'm getting orientation X, Y, Z, W, and the joint type. Joint type 0 is representing your first joint, that is spine base, then spine mini, neck, head, shoulder, all the points, and tracking status too. So there could be 3 tracking status. 0 mean you are unable to track perfectly, 1 mean you are partially able to track, and that means it is inferring data, it is not exact data. And then another is tracking status 2, that you are able to perfectly track the data. This is for one joint. Then this is for joint 2, joint 3, joint 4, and multiple time you will reach this value. So this is how you are getting kindness sensor value. Different activities are performed. Now the question is coming, how you calculate G joint, because you are getting depth X, depth Y, color X, color Y. So for this, you can understand this mathematical description here. Suppose this joint is here, this joint is here, this joint, 2-dimension data is there, X, Y, A, B, and this is CD. You can form the triangle, the acute angle is there, okay, and you can apply cos theta. So suppose this is theta, this is theta. So we have A, B, C. You can have B square plus A square minus C square upon 2ABC. By cos theta we are placing here. This distance you can easily calculate by the equivalent distance. Okay, Ij, Jk, and Jk. And from here you can get E joint value. Okay. For more detail, we have a paper published. So you can refer this paper, IEEE sensor paper. Okay, you can refer my Google Scholar profile. From here you can get IEEE sensor paper by which you will get the history. So first phase of talk I'm finishing here. I will start immediately implementation of our deep learning and TinyML. Okay, so this portion I have covered, how you can analyze or map your data over IoT application for human health monitoring. Okay, how you design the machine learning model. Now I'm coming on the top, in which I will discuss about what machine learning model was there, how you can compress the machine learning model so that you can support the edge computing, how we can utilize different devices, different activities tracking, and we'll see the code also. So if you have any doubt up to this point, you can write in chat box. I'm continuously watching in the chat box. Okay. Sorry, I was in meeting. Are you able to see? There is some connection. Hello, sir. Can you see me?
When you are sharing, sir, the multiple copy of same content is sharing. So once again, you can share.
तो सर आप अभी क्या मुझे देख पा रहे हैं मेरी स्क्रीन सर?
हाँ, आपकी अभी जो पीपीटी है उसमें आउटलाइन वाला जो पीपीटी है वो दिखाई पड़ रही है.
ये अब आप पीपीटी सर, तो मैं बीच में डिस्कनेक्ट हुआ था सर.
नहीं, डिस्कनेक्ट नहीं हुआ था, ठीक था सर.
अच्छा अच्छा,
ओके.
मेरे इसमें वो इंटरफेस नहीं दिखाई दे रहा, इसलिए मैं आई वाज गेटिंग कंफ्यूज दिस वेबएक्स. सो यू कैन सी माय स्क्रीन सर ना?
Moving towards design of
design of
data-driven
data
computing model.
correct. So this is another phase I'm starting now. Okay sir, and in this case now we'll design the deep learning model, and I will demonstrate also over Python code. We'll see the data set also. Everything we'll see. Okay. So this is very interesting. A small work is there, but it is very significant because ultimate objective to contribute for edge computing, to support the edge computing. First, let us understand what is edge device. When we are not using any internet in cloud and IoT application, I was using internet. So data was not that much secure, but in edge computing, I was not using any internet. The device itself has capability to capture the data and process the data. So what I will do, the machine which I will use, this Arduino Nano 33 BLE Sense, which I have with me. It has certain 9-degree sensors, okay, through which I will capture the data. And once I will capture the data, then I will build the model over in my computer, deep learning model. And the deep learning model I will compress. Again, I will fuse over this model because there is processor also, this Arduino Nano, and that can be utilized. So machine learning on the microcontroller. Now I'm going on microcontroller level, that is Arduino Nano 33 BLE Sense microcontroller. Is the most effective, cheap, and reliable way of developing edge computing application, because that is only costing 3,000 rupees, in which you can build entire solution for human health monitoring. Okay, with the low energy consumption. Okay, the limitation is we have very limited energy consumption. So I've used Arduino Nano 33 BLE Sense board and microcontrollers to capture the 5 gestures: square, jump, walk, run, and other. This is for only for lower extremity data I'm doing. Okay, so that's why I consider only the exercise which is related to lower extremities. So that's why I'm using square, jump, walk, and this. This board, Arduino Nano 33 BLE Sense. BLE is ready to Bluetooth device. Okay, sense. Has capabilities such as embedded sensor and the BLE. So already I told that they have 9 capable embedded sensors. And ultimately we'll use deep learning models using capture gesture data to classify the human guesses. So this is your Arduino Nano 33 BLE Sense board. A small board which you can place in the pocket. It has 9 inbuilt sensor. First sensor is LSM 9DS1. This is 9-degree axis IMU sensor. In 9, 3-degree accelerometer, 3-degree gyroscope, 3-degree magnetometer. I'm interested for only this one. Then they have proximity, light, color, gesture sensor, temperature, humidity sensor. Then power LEDs there. The LED color is changing. So different gesture can be identified, different color LED. You can programmable LEDs there. Microcontroller USB port so that you can control also through my ESP boards. It has pressure sensors. And finally, we have microphone to capture the voice and record. And this is Nordic NRP 52840 processor is there. This is microcontroller, and the NINA B306 is Bluetooth module. Okay. First, the benefit is that tiny form factor. It's very small device, only 45 into 18 mm dimension. Okay, that is very small device which you can easily place into your pocket. It is just like your index finger. 9 on-board sensors. This research explore accelerometer gyroscope in a sequence. And the Nordic and RF52840 processor, which has 32-bit ARM Cortex MU CPU, NINA B306 module for BLE Sense. The SRM static RAM is 256 KB, and the flash memory is 1 MB. Operating voltage is 3.3 volt. Okay. Our objective or goal is to showcase the following benefit in the developing edge computing without the sacrificing accuracy. So what I want to do, whatever accuracy I'm getting without compressing, with the modern computer, whatever accuracy I'm getting, same accuracy I want to get through this Arduino board or this microcontroller board. Same accuracy, same level of capabilities. So without sacrificing accuracy of microcontroller, we are achieving cost effectiveness, low energy consumption. We are also getting data privacy because we are using edge computing. We have very tiny form factor and the flexibility is here. The challenge which we have encountered during this implementation, first, once we are sensing data through these 9 sensors, how to capture training data through this Arduino board. So for this, the small Python script was written, which I will share with you, by which you can directly sense the data and store in the Excel sheet. Second thing, that challenge, the size of traditional machine learning model or deep learning model is huge. Loading the model into microcontroller is very difficult. How you can load for this purpose, I have used pruning and quantization technique to reduce the model size. So pruning, somewhat those who are aware of deep learning model drop out and other, they can understand. Okay. So the entire workflow diagram is here. We have utilized this Arduino board to capture the data. Through capture data, we are trying to build a machine learning model. And then finally, once model is prepared, then to see the output of model, we have programmable LED. By LED color we are taking. And second, we are inferring the gesture by the probabilities. Which gesture having high probability, that particular gesture we are achieving. So let us see that data collection phase. 9-degree IMU sensor, which has triaxial accelerometer, triaxial gyroscope. Accelerometer range, which we have considered -4 to +4 G force. G is 9.8 meter per second square. Minus plus 0.1 to 2 mg drift can be possible. Gyroscope is -2000 to +2000 degree per second rotation per second, or many type degree per second. This much rotation, and plus and minus 70 mdps is allowable range of extra which we can move. Magnetometer is micro Tesla, -400 to +400, and there is some allowable range. The sampling frequency of this IMU sensor was, we have considered for this research purpose, 119 Hz. That means in 1 second we are recording 119 rows data. Okay. Each gesture, we have considered 5 gesture: square, jump, run, walk, and other. Performed by 100 times, so total 500 times gesture was performed with sampling frequency 11 Hz. So 11 Hz for one sample. If you are considering for 500, so you can multiply with this one. Data transferred by the BLE board from the center to your computer system. Then Python script discovered to BLE device to establish connection using JTT service. And for particular cases, the data is continuously captured for 1 month, because in one sample we are taking 1 rows. So continuously we have uninterrupted data is taken, and data is sent in the form of string in the sense quantization, so that it can take less size. Okay. So you can see that when I capturing data, you are getting AX, AY, AZ, GX, GY, GZ. This is 3 accelerometer data and 3 gyroscope data. This is 1, 2, 3, 4, 5, 6. For one gesture, for one sample, I'm getting 119. Okay. Ultimately, the deep learning model will look like as, after data pre-processing, we have split data into training, validation, and testing. Training and validation will go together. Testing, once model will train them. Then we have fitted or designed the deep learning model, and we have validated also. We have achieved certain accuracy through the test data. Again, we have compressed this model so that we can fuse over microcontroller. And then we have again tested the model data. And finally, the model interface through LED, we can see. So for data pre-processing, we have already provided the deep learning model as the tensor data. So accept input, generate output in the form of tensor. So the input into the tensor with the shape is 500 into 716. 100 sample for each 5 gestures to total 500 gestures, and 716 each sample. As I told that AX, AY, AZ, GX, GY, GZ for, and you have 119 row. People multiply 119 into these 6 GX, GY, GZ, you will get 716 data for one sample, and you have 500 samples total. 100 sample for each gesture, 5 gestures, total 500 sample. So that's why your tensor size is initially 500 sample, and first neural network input is 716. Output tensor, where you will test your error or cross entropy or whatever you will check mean square error. That time we have 5 gesture and 500 samples are given, so you have 5 classes only. So you have to use 5 one hot encoder matrix of each of 5 gestures. So maybe 0, 1 is for jump, 1, 0 for square and all sort of things. Then finally we have split data into 60 training, 20 testing, 20 validation, sample the input data. We have used 4 layer to any deep learning model in which I am using more than 3 layer is considered deep learning model. So initial layer was 716, first layer 100 neurons, second layer 75, third neuron 75, and finally we have 5 classes, so 5 neurons are there. Each layer I'm using dropout also. So first layer, then dropout layer in there. So it is this way. The dropout percentage is 15%. That means each time I'm out of 100, 15 neurons I'm removing, only 85 are active. Okay. And then finally we are using ReLU activation function for this one. Other parameter for optimization we have used Odom optimizer with learning rate 0.001. Mean square error was considered as the loss function. Accuracy was the measure of matrix. Okay. Then let us understand what is pruning and the quantization. In case of dropout, what was happening? We are losing certain neurons. Okay. But in this case, we are not losing certain neuron. We are removing the some weight. The size is same, but the weight size is becoming less. The reason is that we are prune such a weight which has least importance. The weight which is having very less weightage, we are removing. So what model pruning and quantization, it is reducing the model size. It helps us for faster execution and reduce the power consumption. It is helping. So pruning is the iterative process on trained model that trim the insignificant weight by the setting those weight to 0. It is like ReLU function. If it is negative weight, it is simply making 0. And that's why sparsity will come. Some weight matrix will reduce. So we have not killed the neuron. We have just killed the weight, which is very insignificant. Remove unnecessary connection between. Then another technique is quantization. It is the process to transforming machine learning model into the equivalent representation that is less precise, not that much precise, that use parameter and computation at lower precision. So we are sacrificing precision, but ultimately the data is not lossy. Okay. So quantization is process where weight are converted into lower precision type, like such float 32 to integer 8, so that it can take the less memory size. How it works? Take only the required range used by the float 32 to represent the small number of bits. So we'll see that what is minimum to maximum. Okay, float is -3 into 10 raised to 38 to 3 into 10 raised, and the float integer 8 we are getting -27. Okay, then by applying this formula you can easily scale the data. Okay. Then to see the model interface output, the LED will blink for particular gestures, like square is red, jump is magenta, walk is blue, red, run is green, and other is white color. So now let us see the results. These are for single activities. We are getting 119 sample. This is accelerometer around x-axis, accelerometer data, gyroscope around x, y, z. And gyroscope. This is for one sample. This is for entire 100 sample, or 119 into 100 is almost 11,900. Similarly for jump, walk, run, other activities, then we have trained the model and we have achieved this confusion matrix around these 5 guesses: square, jump, walk, run. So almost we are achieving 96% accuracy. Now we have to compress the model, and after compressing the model, the initial size was 2.1, and after compressing we are getting 0.05 MB. 4 times we have compressed the model and we have achieved almost 96% accuracy. So we have not lost any significance model data. Okay, we are achieving still 96% accuracy. That is the thing. Now you can see the gestures. Okay, the girls will move, perform different gestures. You will see the different color. Now she's performing jogging, standing. So different color gesture you will find. Okay. So and concluding again, I will show you the code little bit. Okay. So this research shows that how simple and efficiently it achieved to as computing support and fuse the deep learning model over Arduino boards. Okay, using human gesture with the real data. Gesture applications showcase all the benefit of microcontroller as mentioned in the code. Along with these benefits, the tiny form factor or embedded sensors can be used as a wearable device and therefore used in building multiple real-time. So now I'm going to show the code, and meanwhile you can keep asking question because I have done with my work. Okay, the presentation is finished. I'm showing the some code. If you can see my screen, you can see my screen. Sir, can you see my screen? Am I audible to everyone?
हाँ सर, यू आर ऑडिबल सर।
हाँ, मेरी स्क्रीन दिख रही है ना सर? हाँ,
स्क्रीन अभी शेयर अप नहीं किए हैं।
अभी ये स्क्रीन शेयर नहीं हुई सर?
शेयर है बट पीपीटी कोई
ये
प्रेजेंट
सर ये नहीं, मैं ब्राउजर दिखा रहा हूँ, ब्राउजर सर।
हाँ ब्राउजर है, ठीक है सर।
हाँ, ठीक है ना?
यूएनसीजी के सर।
हाँ, that I will share with everyone, है ना?
ठीक।
Okay, yeah, you can check. First data section is there, the data is there. So there is 5 gestures: jump, run, square, walk, and set. You can see the CSV file is there. Already well processed data, you can open and check what is inside. So you have 6 column AX, AYZ. This is accelerometer around XYZ. There is gyroscope, GX, DY, GZ. And there is for handed gesture. Handed sample for one gesture. So total you will get 1190. Because in one sample I am getting 119 row. So 119 into 100 you are getting 11,900. Okay, one is for column because already given. This data you are getting. Okay, similarly you will have another gesture. 5 gestures, total 500 samples. After that you can check the code also. Document is also here. PPT's report is here. The gesture code is here, Python code. The Amulya was working as an undergraduate project on this one. So you can see that this is Python code. You can run directly in the Google Colab. So matplot for plotting everything. Only things I have used this one, TensorFlow model optimized sparsity, because I need to quantize and pruning the model. Okay, from Keras as sparsity. You can read each file square.csv, jump.csv, plot AXYZ for one sample or entire sample. Similarly for another jump set, single samples, accelerometer gyroscope data, and for all 100 sample. Once it is done, then you will prepare the model. This is model preparation now will happen. Before this data set parsing and the preparation, you can read this one. Okay, here I am using one hot encoder. You can see the 100 for the square gesture, 0100 for jump, 001 walk, and this way I have divided into output levels. Then what I'm doing is splitting the data into training and testing. So there is Keras, very famous tool. Split the data, 60% for training, 20% you are using for validation, and 20% you are using for testing. Okay. Then model building is here. In model building, I'm using 5 layer, 4 layer. One is input layer, sequential model. Then you are adding the Keras, 100 neurons, activation function value. After that, 15% dropout. Another layer is 75 neurons, 50% dropout. Third layer, and final layer. Adam optimizer, cross entropy, learning rates, mean square error, crossing whatever you want to do. And you can see that the learning accuracy as well as validation accuracy is almost increasing as error is going down. And you can see that Finally, we will achieve 96% accuracy. Here we are getting almost 94 accuracy. Okay. That is model summary, model parameter 85,000 parameters. You can visualize the error also. Loss function is almost going to be after 7 attrition almost negligible, 0.05. Mean square error is also getting 0. Okay, model prediction, you can see that 96% accuracy I am getting. This is our confusion matrix. After that, I need to convert this model into TensorFlow Lite. So there is TensorFlow library Lite is coming. Just you can do TF Lite, TensorFlow Lite converter from Keras. You are passing that model here. And the challenge is coming because in Arduino board you can write in C. This is in Python. So there is TensorFlow Lite which automatically convert your code into header file which you can import into your Arduino board. Okay. Then we have pruned the model. After pruning the models, if you see the accuracy, still we are getting the 96 accuracy. That means we are not losing anything. We are only leaving 97% accuracy. I am adding validation. Okay, so that is how you can do. Code I will refer with you. Already I see the library GitHub. You can use this one. With this, I will close my session here and I will open for question answer. If you have any question answer, you can ask. Okay, and the code is available here, data set, PPT, and everything. Meanwhile, if you find any difficulties, you can mail me also. I will help you later on. Okay, so any question you can write in chat box as well as ask. Okay, so thank you. That was all about my talk, and in the concluding remarks, I can say that we've explored how human gait or health monitoring using for human health monitoring as a IoT application, as a cyber physical system, how different wearable and through kinase sensor you can capture the data. Later on, we have switched on the Arduino Nano BLE Sense embedded kind of device to support the edge computing. And we have seen that the benefit of the less power consumption, fast processing, less memory requirement. And this one, for this we have used TinyML, TensorFlow Lite model we have utilized. So, okay, with this, I will finish my talk. And I will open for question answer. If you have any question answer, you can ask. Yeah. So you can write in chat box also. If you have any query, what is accelerometer? Okay. Okay. Accelerometer also. You can refer on internet somewhat here. Now. Today you download this Android app. Okay. Anyone who is interested, they can download this Physics Toolbar accelerometer, free available app in Arduino board, and it has all sort of sensor. From here you can visualize accelerometer, gyroscope, magnetometer. Okay. Now the question is coming: what is accelerometer? Okay. So coming on this one, though I have written some specification here, I have depicted somewhere accelerometer. Anyway. So generally human body has 3 degrees, 6 degrees of any solid. You consider this solid. Okay. This is suppose solid. You can represent by 3 axes: x-axis, y-axis, z-axis. So whenever you have motion, you can move around x-axis, y-axis, z-axis. You can rotate around x-axis, y-axis. If body is free body, not fixed anywhere. So you have total 6 degree of freedom. 6 degree of freedom. 3 translation, 3 rotation. So basically, accelerometer help us to capture the acceleration in direction. If car is running in particular direction, how Google Earth, Google Map is helping which speed you are moving. It is through accelerometer only they are capturing that what speed your car is moving. That is in x direction, forward y direction. If you want to check the orientation around x-axis, कितना आप move किए हो, that you can capture by gyroscope. How much angle you are moving around x-axis, y. अभी आप लोग सीखोगे. Later on, that time you will understand. So accelerometer, and generally we used to measure accelerometer into g-force. Accelerometer will give the acceleration meter per second square, which you can read in the g-force also. G-force is nothing but 9.8 meter second if you are on the earth. If you are moving on different surface, then it will change. Okay. And for our case, accelerometer is taking the range of 9.4 accelerometer. I think that's the question. What is accelerometer? How to recognize the real-time gesture, any software or hardware required. In terms of real-time gesture recognition, so you have to train your model with the pre-set of the gestures, at least broad category of gestures. Then at least you can classify the category, which category of gesture is there. Okay. So far the software, in the sense people are writing Python code, many Python code, you can see that as such no particular software is available to recognize the gesture. In OpenCV maybe you can done, you can do this also, OpenCV, but irrespective of any programming language, the principle is that first you have to train the model, deep learning model. Once model is trained, any device you are purchasing, device will have capture, because you require camera which can capture the gestures and you can identify. Hardware we require to capture the data, either you can go for kinetic sensor, or either you can go IMU sensor. Already I placed now this kind of IMU sensor also you can go. This has already IMU sensor, but IMU sensor, this hardware, inertia measurement sensor, or you require kinetic sensor. And kinetic sensor you can place the difference, and IMU sensor you can wear also. So once you have captured the gesture data, and already you have to build the model. Once model has built, and nowadays many devices are coming which itself define some gestures. Any more question? I think that I'm clear about this one. IMU sensor, inertia measurement unit sensor, which is 9-degree IMU sensor is coming. 1,000 rupees you will get this one. 1,000 also high. Accelerometer you are getting hardly 200, 300 rupees, which is helpful itself. Accelerometer and gyroscope is helpful. So better you purchase a 6-degree IMU sensor, and by which you can capture the data, you can place, and you can track the activities. You can refer, I will share my Google Scholar so that you can understand what quality of work we are doing, and it will be helpful maybe. You can visit my website, and there is some publication I have uploaded, some ResearchGate, maybe you can find some techniques. You can post many times if technical difficulty you are finding, you can search on ResearchGate also. They are also providing very unique solution. Any other question? If you have no question, then I will stop here. I think that there is no more question. Okay, thank you for all the things. Yeah. So Dharamveer sir is here. I think that no more question from participant side. Thank you for appreciating. Okay, with this, I will finish my talk here. Okay, anyone is here? With this, I will
I think
close.
sir, किसी को कुछ doubt नहीं है. I think we can conclude here.
Yeah. So already I concluded, and maybe they have not. They have asked questions, sufficient questions. Yeah.
Okay, thank you, sir.
Okay. Okay, sir. Thank you.
This session. Okay, thank you, sir.